Hey everyone, welcome back to AI Academy. Have you ever wondered how Netflix knows exactly what movie you want to watch next? Or how Amazon seems to read your mind when suggesting products? Today, we're diving deep into the fascinating world of recommendation systems, the invisible engines powering personalized experiences across the internet. By the end of this video, you'll understand exactly how these systems work, their architecture, and why they're absolutely crucial in our data-driven world. So grab your coffee, hit that subscribe button, and let's get started. So what exactly are recommendation systems? Think of them as your personal digital assistant that never sleeps. They're intelligent algorithms designed to predict and suggest items you might be interested in based on massive amounts of data and patterns. Look around you. They're everywhere. Netflix recommends movies and shows tailored to your taste. Spotify creates personalized playlists that somehow know your mood. Amazon suggests products before you even know you need them. YouTube's algorithm decides what video appears next in your feed. But it's not just entertainment and shopping. LinkedIn suggests connections, news websites curate articles, dating apps show potential matches, and even your email client sorts spam. These systems process millions of interactions every second to make our digital lives more relevant and less overwhelming. The key word here is personalization. Instead of showing the same content to everyone, these systems create a unique experience for each user. Pretty amazing, right? Now let's break down the three main types of recommendation systems. Each has its own superpower. First up, content-based filtering. This approach is like having a friend who really knows your taste. If you love action movies, it recommends more action movies. If you buy organic foods, it suggests more organic products. It analyzes the features of items you've liked and finds similar ones. Simple but effective. Next, collaborative filtering. This is the wisdom of crowds approach. It looks at users who have similar taste as you and recommends what they liked. It's like saying, hey, people who bought this also bought that. Amazon made this famous with their recommendation engine. Finally, hybrid systems. These are the powerhouses that combine multiple approaches. Netflix is a perfect example. They use content analysis, collaborative filtering, and deep learning. They consider what you've watched, what similar users watched, the time you watch, the device you're using, and even where you paused or rewatched scenes. Most modern platforms use hybrid approaches because they're more accurate and robust. Why limit yourself to one technique when you can use the best of all worlds? Let's pull back the curtain and see how these systems actually work behind the scenes. The architecture follows a beautiful four-stage pipeline. Stage 1, data collection. Everything starts with data. Every click, every rating, every purchase, every like, it's all being collected. For Netflix, that's 300 plus million users, generating billions of data points daily. What you watch, when you pause, what you skip, even how you scroll. Stage 2, data processing. Raw data is messy. This stage cleans it up, handles missing values, and extracts meaningful features. For movies, this might mean extracting genre, director, cast, release year, and even analyzing the actual content using computer vision and NLP. Stage 3, model training. Here's where the magic happens. Machine learning algorithms learn patterns from all this processed data. They might discover that users who watch sci-fi also tend to like thriller movies, or that people shopping for laptops often need laptop bags. The final stage requires serving real-time predictions. When you open Netflix, the system instantly calculates what you're most likely to enjoy right now, considering your history, current trends, and even the time of day. Here's a simplified example. Imagine a user movie rating matrix, where we're trying to predict missing ratings. The system learns patterns from known ratings to fill in the blanks. User 1 gave movie 1 a rating of 5, but what would they rate movie 2? That's what we're solving. Let's dive deeper into collaborative filtering. It's like having millions of personal shoppers working together. User-based collaborative filtering is intuitive. The system finds users who are similar to you based on past behavior. If you and John both love Marvel movies and Korean dramas, and John recently watched a new sci-fi series you haven't seen, the system will recommend it to you. It's digital word of mouth. The process is elegant. First, calculate similarity between users using techniques like cosine similarity or Pearson correlation. Then, find your neighborhood of similar users. Finally, predict ratings based on what your neighbors liked. Item-based collaborative filtering flips this around. Instead of finding similar users, it finds similar items. If you loved The Matrix, it analyzes all users who also loved that movie and sees what else they enjoyed. Maybe they also loved Blade Runner and Ex Machina. Boom, recommendations ready. But here's where it gets really cool. Modern systems use matrix factorization. Instead of comparing users directly, it discovers hidden factors or latent features. Think of these as personality traits for movies. Some movies score high on action intensity, others on emotional depth. Users also get scores on how much they like each factor. This approach, popularized by the Netflix prize competition, can handle millions of users and items efficiently. It's like creating a DNA profile for both users and content. Content-based filtering is like having an incredibly detail-oriented librarian who knows exactly what you like and why. Step 1. Item profiling. The system analyzes every aspect of content. For movies, it might extract genre, director, cast, plot keywords, cinematography style, even audio features. For recipes, it looks at ingredients, cooking time, cuisine type, dietary restrictions. Modern systems even use computer vision to analyze images and NLP to understand text descriptions. Step 2. User profiling. Based on items you've interacted with, the system builds your taste profile. If you consistently rate action movies highly, your profile gets a high action preference score. If you always skip romantic comedies, that preference gets downgraded. Step 3. Similarity calculation. Using techniques like TF-IDF or cosine similarity, the system finds items most similar to your taste profile. It's like mathematical matchmaking between you and content. The beautiful thing about content-based systems, they don't suffer from the cold start problem. New users can get recommendations immediately based on just a few interactions. Plus, the recommendations are explainable. We recommended this movie because you liked other sci-fi thrillers with strong female leads. However, they can create filter bubbles. You might miss out on discovering new genres because the system keeps recommending similar content. That's why hybrid approaches are so powerful. Now, let's talk about the real-world challenges these systems face and the ingenious solutions engineers have developed. Challenge number 1, the cold start problem. New users have no history, new items have no ratings. How do you recommend to someone you know nothing about? Solutions include asking new users about their preferences, using demographic data, or leveraging social media profiles for initial recommendations. Challenge number 2, data sparsity. Most users rate very few items. In a dataset with millions of movies and users, the rating matrix is over 99% empty. Matrix factorization and deep learning help by learning from patterns in the sparse data. Challenge number 3, scalability. When you have hundreds of millions of users and millions of items, traditional algorithms break down. Solutions include distributed computing, approximation algorithms, and smart sampling techniques. Challenge number 4, filter bubbles. Over-personalization can trap users in their comfort zones. Modern systems balance accuracy with diversity, occasionally recommending content outside your usual preferences to help you discover new interests. Challenge number 5, changing preferences. Your tastes evolve. You might have loved romantic comedies in college, but prefer documentaries now. Systems use time decay functions, giving more weight to recent interactions and continuously retrain models. The solutions are fascinating. Hybrid approaches combine multiple techniques. Deep learning models can capture complex, non-linear relationships that traditional methods miss. Real-time learning systems update recommendations instantly. Context-aware systems consider your current situation. Different recommendations for a weekend evening versus Monday morning commute. So what's next for recommendation systems? The future is incredibly exciting. AI and deep learning are revolutionizing the field. Neural collaborative filtering, autoencoders, and transformer models, yes, the same technology behind ChatGPT, are creating more nuanced understanding of user preferences. These models can capture complex, nonlinear relationships that traditional methods miss. Multimodal data integration is huge. Instead of just using ratings, future systems will analyze images, audio, video, and text together. Imagine a fashion recommendation system that understands your style from Instagram photos, or a music system that recommends songs based on your current activity detected through your smartwatch. Real-time adaptation means systems that instantly adjust to your mood, context, and current situation. Different recommendations for rainy days versus sunny days, for when you're alone versus with family, for your morning commute versus weekend relaxation. Here's what I want you to remember. Recommendation systems have evolved from simple, people who bought this also bought that, to sophisticated AI engines that understand context, respect privacy, and balance accuracy with discovery. They're not just convenient features anymore, they're essential infrastructure for navigating our information-rich world. Without them, we'd be drowning in choices, unable to find content we actually want to consume. What fascinates you most about recommendation systems? Have you noticed how they've influenced your digital behavior? Drop a comment below. I love hearing your thoughts. If you enjoyed this deep dive, smash that like button, subscribe for more tech content, and ring the notification bell. Next week, we're exploring neural networks in depth, so you won't want to miss that. Thanks for watching, and I'll see you in the next video.